Hello everyone, I'm Thaw. I'm a Hitachi Energy Apprentice student at AID. IEEE PES Student number 981-88096. My mandate is Data Pradipun Susiti Tawakun. He is a vice president at Hitachi Energy in Thailand. Today, I would like to present my title is Grid Founding Inverter for Grid Connected Microgrid. Next slide, table or content, introduction, solar diesel flywheel in microgrid power generation at Marble Bar, Western Australia. Transition to a new grid is not without problem. High renewable penetration, advantages of grid connected microgrid from microgrid and grid respective. Grid founding inverter with PSN functionality in operation, a first future grid without the edge registry, conclusion and reference. Introduction, the electric power grid is in transition for nearly 150 years. It has supplied power to home and industrial load for synchronous generator situated in large centrally located saturation. Today, we have more and more renewable energy sources, photovoltaic, solar, and wind connected to the grid by electronic converter. A grid is strong will provide a stable and clean that they are able to inject real power into the grid without undue impact on its operation. With carbon neutral target around the world, countries require an even increasing penetration of renewable energy. Next slide. Solar diesel flywheel microgrid power generation at Marble Bar, Western Australia. In this figure, Islanders Power is a remote microgrid figure has approved to be good at incorporating and high penetration of renewable energy source. Transition to a new grid is not without problem. Synchronous generator. Synchronous generator are rotated machines typically driven by an inverter or engine as shown in figure 2. Turbine may be driven by using steam, water, wind, or other fluid as an intermittent energy carrier. The most common usage is by steam in fossil fuel power plant or nuclear power plant, water in hydropower plant. Here is the grid connected to the synchronous generator and then connected to the diesel and then connected to the synchronous speed. Figure shows synchronous generator driven by diesel engine with control system. Next slide, high renewable penetration. High renewable penetration is not a great issue today. In Australia, the share of renewable energies grew from 40% in 2009 to 51% in 2018, dominated by wind power. Power system had experienced instantaneous penetration from wind generation in excess of 140%, the higher for any major power system in the world. Renewable such as wind and solar power suffer from intermittency. The availability of the parameter so is variable in an uncontrolled way, and variation occur quickly in seconds. Microgrid from remote power provider to grid connected supporter. A microgrid consists of collection of generation assets and load. The benefit is usually a reduction in operating costs or maximizing profit. The difference between microgrid and coordinate generation plant load side is availability of the microgrid to island usually seamlessly and on demand. Grid strength is not all about short circuit current. Short circuit currents and short circuit ratio had been simple metric for grid strength, but that is not the whole story. Grid strength is not the combination of the following: low interior, low body regulation, power frequency regulation, low force current, and low spanning result. In essence, it's all about frequency and body stiffness, not about the area. Energy storage has solved weakness. Figures show the comparison of grid connected or guided synchronous generator dominated and renewable generation. This figure show guided traditional synchronous generator dominant, low renewable penetration, high renewable penetration. Inverter and their control. A typical three-phase, two-level power electronic inverter and its controller are shown in figure. At the heart of the inverter are power semiconductor switches. Advantages and disadvantages of grid connected microgrid from grid connected perspective. Microgrid perspective and grid perspective. In microgrid perspective, access to grid energy at lower trade, capacity trading, reliability, body disturbance shaping. For grid perspective, reducing load, fan capacity with scheduling generation, frequency control, and utility service, nominate and spread, now support stability, damping at the end of the both and beta rear-day injection, feeder scheduling as a service without a local update. In this figure show power electronic inverter are software control and their functionality can be changed even though the hardware stayed the same. Figure 4 represented the full range of inverter control level, which include the following. In unit control is close to the hardware and had the first loop. Primary control is the way in the added logarithm, including statistic synchronous comparison and frequency suppose are executed cycle speed of 2 to 5 kHz are typical. Secondary control method related to local system level control and automation. Tertiary control enable wide system optimization, such as maintaining megawatt exchange between zone, remote set point, and optimal operation based on focus. Cloud loop data and cooperation, analysis, optimization, and monitoring and tertiary control, and then secondary control, and then primary control and unit control. Unit control is close to hardware. Inverter using as a current or body source. In a sound grid, the unit controller tracks the grid body by PLL, then as in a current control mode to insert the required real and reactive power. If the inverter behaves as a controllable current source and follow the grid body, this is also known as a grid following inverter. Alternately, the unit controller can function in a body regulation mode when it's governed the output body to have the required magnitude, frequency, and phase angle. In this case, inverter is added as a controllable body, so forming a body at a terminal, a so-called grid founding inverter. Inverter need more than grid founding inverter. This figure secondary and tertiary load sharing, and then grid cabana plus loop, and then interior for bodies. Figure 5 show a header load sharing in parallel connected generator, each with its regulator output impedance. Grid need more than grid founding inverter. In sum, a grid has a particular strength for optimal operation, and one can we say between its strength and compliance by the following. When the strengthness is too high, low variation is not shared with distributed ratio with the grid, and these ratios do not participate in frequency and body regulation. As a for current that is too low, measure production system do not appropriate and require SMA to take too long to blow. Synchronous generator had the right mix of characteristics, so they are straight enough for grid robustness and compliant enough to enable low variation sharing with other resources. A comparison of grid following and grid forming inverter. It has advantages and disadvantages for grid following inverter. In advantages, simple control, very fast response time, suitable for IE grid interface, ability in rotating and stationary frame, automatically limit current to and for. For disadvantages, does not contribute to grid stress, require a strict grid, PLN losses throughout the grid, frequency 2 and 4 cannot be grid master, limit to person on a grid. Grid founding inverter bodies to grid master can run in stand-alone mode, can run in regrid, highlight load changer without disturbance. For this advantage, desynchronized 2 and 4, 2, 3 in pure 4, do not share with legendary synchronous generator. PSM control system. PSM control figure 6 show a PSM control system consists of 5 bar, an automatic body regulator, rotor flex model, a frequency governor, anterior and virtual impedance. The first is a virtual impedance RP+GAP having a response that recent event impedance at the output or a synchronous generator. This is the key to creating a grid founding inverter that can be parallel with other or its kind synchronous generator and the grid. Rotor flat model and automatic body regulator make the reactive power body magnitude dynamic like those are asynchronous generators, so there is a great amount of sharing during the transient with 10 over 10 mid similarity. The anterior model and frequency governor make the PSM has added power frequency dynamic like those are asynchronous generator. PSM tripping show a comparison of the response to a figure A 300 rate or changing of frequency. Figure B, a PSM and BBS synchronous matching in a simulation. The weight and response of the PSM is possible through the anterior dynamic parameter setting. The damage of the SM is defined to their respective delta, winding, geometry, and concretion. Grid founding inverter with PSM functionality in operation. Figure A show a grid founding inverter battery energy storage was installed in an industrial state in northern Marble to support a grid and all the line feeder. Figure A show a grid energy storage system for an online distribution grid support. Seamless islanding. Once transition from grid connector to islanders mode as shown in figure, show the battery energy storage taking on entire downward load. Figure then show the grid forming inverter battery energy storage in islanders mode. The figure then shows the downward stream now being reconnected to the our stream feeder, battery energy storage taken to the entire downward stream load. When the load flow across to the our stream breaker is 0, the breaker is open when the battery energy storage loading supply to the microgrid. The generator is set at a battery energy storage and generator share the downstream feeder load before a stage shutdown is performed. Microgrid body draw. When operating a body operating mode, I illustrate in figure 11. Figure 11 shows the reactive power delivered to the upstream downward and downstream downward. The downstream downward feeder by the battery energy storage and generator. temper battery energy storage system and substation. Figure 12 displays the temper battery energy storage and substation with a specified diagram of the system. Microgrid consists of 33 kilovolt feeding the rural load and battery energy storage and downstream 132 kilovolt line to 91 megawatt with another temple reforming battery energy storage 300 megawatt by 808 megawatt hour battery energy storage and microgrid automation system. Figure 30 show a positive as ROCF event show the anterior response from the temper battery energy storage. Figure A, 8-second frequency view. Figure B, 8-second address power view. Figure C, 300 millisecond frequency view. Figure D, 300 millisecond current waveform. Simplest islanding. Red color show waveform 1, green color show waveform 2, and blue color show waveform 3. Figure A show body, figure B current waveform record the 33 kilovolt recognition on the point of the GF battery energy storage before and after islanding instead marked by the red particle line. Special network support. Figure 50 represented the temper set event at 6 p.m. The SIP trigger is sent from the centralized control system after a 40 millisecond communication delay to the microgrid, followed by a controller 400 millisecond connection delay with the microgrid. Affect future grid founding at the legislature. As we have seen, grid is in transition with generation moving from mechanically driven to electronically driven sources due to the attempt to the integrate renewable. So, what are the future? When a large percentage of the total generation is from inverter, and there is even a through inverter based grid that is made sense to emulate the synchronous generator. Inverter has much faster timing as they are not independent of mechanical characteristics, so as an inverter-based grid could respond more quickly to changes. One of the microgrid or inverter is that they are software controlled, therefore software can be updated to change its behavior and the control parameter can be adapted to changing grid condition. As the number of inverter in the grid increase, it may be that synchronous generator will change so that there is a slow base load generator. Conclusion. To meet the carbon neutral target, electric grids must be accommodated at high percentage of renewable energy, so we are connected by inverter. As more inverters have been added, the grid has become weaker with increasing body and frequency variation. IBS must be controlled so that we operate in compatible way with the existing grid. Remote microgrid provide an example of the BSM and possibility to operate with 100% renewable sources where energy storage is at. Now applying BSM to grid forming inverter, we can take the grid full of good citizens that provides stable operation and 100% renewable penetration with recently. Here is the reference of my study. Thank you for your kind attention.